So here's a cool theorem due to a guy named Fubini. It says, and I am making this as, I'm making the worst possible version of Fubini's here, basically. Okay? Fubini's is a lot stronger than this, but I'm just making some wild assumptions, and then I'll phrase a slightly different version afterwards. So if f is continuous on a rectangle, then the double integral of f, and maybe let me give you, my rectangle is AB by CD. Okay? So if I'm integrating from C to D first, what variable is that with respect to?
dy.
Y. And then dx. And that should be the same as if we integrated from C to D on the outside and A to B on the inside. This would be f of x and y is, f of x and y dx dy. And I'm even going to say that this is actually the integral over the rectangle of f of x and y d area, just to drive home the point that this is one realization of that number. Cool?
Okay.
And then I'm going to give you the looser phrasing of Fubini's. So this basically says if you have a continuous function on a rectangle, you can swap the order, right? Okay. Looser version. If you're doing engineering, this is always true. Okay. So even if you're doing engineering with a function that's discontinuous, this is still going to be true.
Because you're not going to crack an item that goes off to infinity. You know?
No, you might still, and that would actually be okay.
So,
You'll get infinity in either direction, right? Like if you integrate with, if you have some function that has a vertical asymptote in the middle of it, and you try to integrate over a rectangle that includes that vertical asymptote, it's not actually going to matter if you do dx or dy first. You're going to get infinity either way.
oh.
You guys see that? So this thing's a little bit funky, right? Because it's not saying this is a nice number, right? This could be divergent.
It says they're the same number.
But they're the same
Okay.
either way. You guys see that? To get a function where these two things are not the same takes some serious pathological mindset. Okay? So if you're working with a function that came out of the real, out of a real world problem, this is probably not going to happen. To construct an example where Fubini's doesn't hold is fairly hard. Let's go with that. It is possible mathematically, but you will not run across those things building bridges.
Maybe building wormholes.
Also not building wormholes.
Or black holes?
Or objects in the universe.
Okay.
Cool? Matter doesn't work fine enough for these to be the case.
Interdimensional travel? I'm just throwing things at you.
Doesn't matter. Insert physics concept. You're doing engineering.
I don't know, physics can get pretty weird.
Physics can get pretty wild, but so the thing is, to break this, you have to be able to divide things into infinitesimal pieces and then regroup them, and you can't do that. Like, physics doesn't let you cut things up into finer and finer pieces forever, right? And even if it did, it wouldn't let you cut them up and then recombine them. Cool? All right. So for you guys, right, you can switch the order of integration. It'll be fine. Good? Okay.